Fusion can be used to create circuits, and these circuits can be used to create printed circuit boards, or what are called PCBs for short. And PCBs can be converted to 3D models and used within Fusion to see how they fit into a product's enclosure. But have you ever wondered, what is a circuit? Well, welcome to What's a Circuit, the first in a video series of basic electronics using Fusion. Circuits require a power source and a complete path for electric current. Just like a racetrack circuit where cars race from start back to the finish line, electric current flows from a source terminal of a power source back to the return terminal of the power source. In the early days of electricity, it was thought that an electric fluid flowed through conductors from the positive or source terminal to the negative or return terminal. This convention, established by Benjamin Franklin in 1750, is still used today, and we call this conventional current flow. It was later discovered that it's electrons that flow, and that they flow from negative to positive. We call this electron flow. However, names like source wire or return wire, as well as circuit symbols and schematic drawing conventions, all reflect conventional current flow, and conventional flow is used to this day. Drawing pictures of our circuit can take a long time, and so we use schematic symbols to represent components in a circuit. In Fusion, adding a part places the schematic symbol into the schematic. Parts in Fusion also have footprints needed to make PCBs, and may also have 3D models and electrical simulation data as well. So why do Fusion schematics, or for that matter any schematic, look so different? Well, partly it's because of shortcuts we use for power sources. The negative terminal of the power source in most circuits is called ground, and we represent that using the ground symbol. And the supply rail, or terminal as it's sometimes called, is replaced by a supply rail power symbol. Supply connections are often just shown as a connection to a supply symbol. This declutters schematic and makes them easier to follow. In the early days of electricity, it also saved a lot of drawing time as lines between supply connections could be omitted. These circuits are identical. The connection to the plus V symbol means that these 2 points are connected together. And the connection to ground means that these 2 points are connected together. Here's an example circuit with power connections to multiple components. I'll highlight them in yellow. Notice how it becomes less cluttered when we use ground symbols and supply rail symbols to represent those connections. Note too that this saves time as we don't have to draw the lines between components to show the connections. There are other schematic symbols that can be used to represent power supply connections. Some supply rail symbols use arrows, some use small circles. Ground symbols can also vary in appearance, but they all mean the same thing: a connection to a source or return wire on a power supply. The key thing to remember is that circuits require a power source and a ground connection. Next in the series, we'll look at voltage, current, resistance, and Ohm's law.